right, this is SAT practice test 5 from the Bluebook. The whole math section is supposed to take 70 minutes. I'm going to do it in about half that time, get a perfect 800, and walk you through every shortcut I use along the way. By the way, I built a tool to help students practice exactly this kind of thing, and I'll show that to you in the middle. Let's go. So this first question here, let me open up Desmos. Don't need it for this first question though. It's just a reading question. You got to pick the correct linear equation. And when we kind of read this, it says a veterinarian recommends that each day a certain rabbit should eat 25 calories per pound, right? So here's our first key phrase, right? What you kind of want to remember with this, when it's in slope-intercept form, right? Two keywords for slope, it's going to be per and each, right? So when I see 25 calories per pound, I know that's describing the slope, and then it says plus an additional 11 calories. So that's going to be D, 25x plus 11. Next one here, this is a conversion problem, right? That's also something you'll commonly kind of see, right? So for conversions, where we go, here it is. It's just basically doing stoichiometry, right? So if you've done chemistry, you should be familiar with this. It's just dimensional analysis. You're going to multiply by whatever conversion factor they give you, and you want to make sure kind of like whatever you're trying to cancel out lines up on kind of like opposite ends. So like here you see feet on top, then over here feet on bottom. Therefore, the units of feet can cancel out. That's basically what you want to do. They'll provide you all the conversion factors you need besides like time ones, right? So here they tell us the camera is at a depth of 39 fathoms, right? So I can write it something like this, 39 fathoms over 1, and then just multiply by my conversion factor. So I would put 6 feet on top and it would be 1 fathom on the bottom. That's because I want these units of fathoms to cancel out. So then all you do is just, go ahead and multiply those, write it without the units, and Desmos will do the math, right? So I just put the units there just so I can make sure everything's lined up correctly. But that's it for number 2 there. Number 3, okay. Angle relationships, right? If you see angles here, they tell us line M is parallel to line N. Whenever you see angles, we got to know our angle relationships. So here's a graph for that, right? So when you have parallel line relationships, right? And parallel lines, right? These things are true only if we have parallel lines, which we do here, right? However, these two over here, you kind of want to know, they're true in every situation about angles, linear pairs and vertical angles. So here we are dealing with vertical angles. That's when they're right across from each other and they have to be equal to each other. So we know the answer here is C, right? Okay, next one here gives us a function, f of x equals 14 plus 4x. When they give you a function, they'll describe to you what the things are in a function. So here it says F represents the total cost in dollars of attending an arcade when X games are played. And they want to know how many games can be played for a total cost of $58, right? So with functions, is a very common thing. You need to understand what's X, what's Y, because they'll give you X or Y and you find the other one, right? You can only have one unknown. So in this case, they're telling us the 58, that's the Y, and then we're trying to figure out the games, which is X. So if you just type that into Desmos and you zoom out, right, Desmos will just solve it for you. It's 11, right? So that's a really cool thing about Desmos. This next one, you probably don't need Desmos. It's honestly pretty simple, but I'll show it to you anyways, just for the people who aren't as kind of advanced and are just kind of picking this stuff up. Yeah, you could put this in Desmos, right? Just like we did for that one. If you type an equation into Desmos, it will just solve it for you, right? So here, I put this in, I learned that X is 1, right? So they don't have that as a trap answer. Be careful, a lot of times they do. Make sure you answer the question you really need to answer, which is what is the value of X minus 7? So if I know X is 1, X minus 7 is negative 6. That's it for 5. Number 6, the amount of Hannah's bill for a food order was $50. Hannah gave a tip of 20% of the bill. What is the amount in dollars of the tip Hannah gave? Yeah, this is honestly pretty simple, but one key word that's going to be important going forward in other percent problems is this word of, right? Sometimes with percents, you literally want to just like translate them, right? And of is a keyword that means multiply. So we're going to take 20%, multiply it by the amount of the bill. That's literally what it says. So 20%, you could probably write that as a decimal. You know what that is. But for people who don't, any percent, you can just divide by 100 and it'll write it as a decimal. You don't have to think about it that way, right? So it's of, so times, and then 50. So we get 10. 10 is the amount of the tip, and that's it for 6. Number 7, we got, some data here, 5 different nests, 5 different numbers of eggs. It says a 6th nest with 121 eggs is added to create a new data set. Which of the following correctly compares the means of the 2 data sets? So this is something you can do in Desmos, right? You can answer this without, kind of using Desmos, and I'll kind of explain how. But for those that don't know, this is a good thing to know. If you want to answer mean, you see, I can just type the word mean, right? And I can just type in my numbers and it'll tell me what the mean is. So this is the mean of the original, right? The 5, nests that we currently have. And it asks if we add a sixth number. So you see, really easy. All I do is I just add a sixth number, and I can see it was 143.2 for the original. And when I add 121, it goes down to 139.5, right? So now I know it. I know that the original is larger or the newer one is smaller, right? Just make sure you get the order correct. So here it says original data set is greater. So that's the one we want. But yeah, you don't really need Desmos for this, right? If you kind of know about mean, if you add a number that's a lot smaller than all the other numbers, well, the mean's going to go down, and vice versa. If you added a number that's much larger than your current set of numbers, the mean will go up, right? So you can answer it that way as well. All right, this one, total freebie, right? Just match it up, right? Like literally just type these into Desmos. So you see, if I type in answer choice A, right, it's just going the wrong direction. This is going up and to the right, but this is going down and to the right, right? So it's not A. So if I change it to B with a minus there, right? Now it looks like it's going in the right direction, but it's shaded on the left, whereas this picture is shaded on the right. So that's not it either, right? So if I try C, right? C just flips this sign, makes it plus 3x, right? If I try that, no, so that's again going up and to the right. That's not what we want. So finally I change it to D, and we see D has everything. It's going down and to the right, and it also has the shading on the right side. So inequalities like that, generally just put it in Desmos, should be freebies. Here's one where you probably want to do it without Desmos, right? To be honest, right? So you could do this with Desmos. It has keyword equivalent. These are pretty common problems. We might run into another one on this test, right? And we're not going to show you like how you can do that in Desmos. It'd be kind of a little overkill. I feel like in this one, you should just be able to do this, right? You know, some things you just, want to be able to do without Desmos. They're just quicker that way. This, we just got to simplify. The only thing you got to watch out for is distribute this negative to both the terms, right? Because they always have a trap answer waiting for you if you don't. So it would be 8x cubed minus x cubed. So it's got to be 7x cubed, so we can eliminate A and C. And then it's 8, and then it would be plus 2, right? So we get 10. So that's it. Next one here, it wants a line T passes through these 2 points. What equation? Oh, this is a great one for Desmos. If you go to this plus sign, you add a table, you put in your 2 points, right? This button will appear here at the top left. Click that, add regression. You see, you get your equation. If you want to use the equation, you can click that button. Here we don't need to, but that's my equation, so I know it's D, right? Freebie, anytime it wants an equation of a line, that's what you should do. Okay, next one, another freebie, right? This is a keyword to remember, solution, right? We already kind of saw this. Any equation you type in, Desmos will give you the solution, right? Small issue pops up with this one, right? You see, if I type this in, I'm gonna get an error, right? So what's an error? An error is like when you get this triangle here in Desmos over here to the left. You see that? If you got that, you entered in something incorrectly, right? Otherwise, you'd see kind of like a color, right? Which I'll kind of show you. So the issue here is Desmos only wants equations with X, right? So all I got to do is just change D to X. You see this switches to a color, which means we're good to go, right? So if you zoom out, then you see I can click on the 2 solutions, negative 30 and 30. In this case, you can answer with either one, right? Sometimes they'll give you more specific instructions. They'll be like, give me the positive one or give me the largest one, right? So here they'd accept either one. I'll just enter in 30. Next one here, a store sells 2 different size containers of blueberries. The store sales of these blueberries totaled $896.86 last month. The equation 4.51x plus 6.07y equals 896.86 represents the situation where x is the number of smaller containers and y is the number of larger containers. It's always, you want to be on the lookout for that anytime you have variables, right? They're going to describe to you what the variables are, right? So x small, y large. And it says, according to this equation, what's the price of each smaller container? Well, remember, x is the smaller containers, right? So that's 4.51x. So what's the price? It's just 4.51. There's absolutely no math here. It's just reading and interpreting, right? Next one here, right off the bat, if you get an equation, you want to identify what kind of equation you have, right? It's a really good habit to make, right? Because there's certain things that only apply to certain equations, right? If it's linear, it has slope, right? But we're not really going to think about slope for quadratics or exponentials. Not that they don't have it, but you need calculus, right? Which is outside the scope of this test, right? So this is an exponential model, right? So we want to understand our exponential model. So we got that somewhere here. Where's our exponential model? There it is. Okay. So our exponential equation, here it is. It really has 2 important parts, right? The number out front, that's the y-intercept. We can think of it as the initial value, right? And we kind of have this number inside here, which is going to be represent our percent increase or decrease, right? We do 1 plus r for increase, 1 minus r for decrease. So since this is 0.5, it has nothing to do with this problem, but 0.5 would be a decrease because it's 0 point something. In fact, it would be a 50% decrease. This question, though, if we read it, says the function f models the intensity of an X-ray beam in the in number of particles in the X-ray beam, T millimeters below the surface of the sample of iron. According to the model, what is the estimated number of particles in the X-ray beam when it is at the surface, right? So kind of at the surface is implying like the initial value, right? Because T represents how far we go below the surface. But again, I know that because I know this question is always either about this or this. Sometimes it's about the exponent, but typically like 90% of the time it's going to be about the number in front or the number inside, right? So you kind of want to know initial, and also the other one describes the, kind of change, right? So the answer here is just 500. That's what it is at the surface. The way you can do that mathematically is, again, T they said is milliliters below the surface. So if you're at the surface, you're 0. T would be 0. If you plug in 0, you're going to get 500, right? Okay, next one here. This question, they give us a graph, and it says, which of the following is the graph of y equals f of x plus 5? This is a transformation problem, right? So here's our transformations. They're basically just test you on translations and shifts. I've really never seen things about like stretches or reflections, to be honest, right? But you got to know these, the translations and shifts, right? So if you write something like this, f of x plus 2, that's kind of what we have here, right? It says f of x plus 5. That's going to mean up to, right? So if it's on the outside, that's vertical, whereas like over here, you see, if it's on the inside, that's going to be like left and right. So just make sure you kind of understand these. So this is telling me I'm looking for a graph that's shifted up 5 units, right? So you want to find a key point. So like right here, you see, I see it's kind of like flattening out here at the value of 1. So if it was shifted up 5, it would be flattening out at the value of 6, right? So that's what I'm looking for. So not A, right? That doesn't have it. Not B, not C. D, right? This is the only one you see. It looks like it's flattened out around 6. So that would be it for 14. Okay, next one here. Which equation? It basically gives us an equation, and it wants us to kind of like rearrange it, right? So there's a couple ways you could kind of do this. You absolutely could do this in Desmos. I'll show you how. It's kind of a cool thing. You could also do this algebraically, so I'll kind of show you both, right? So like here, if I write this, just so I can show you kind of like the algebra on my screen, since I don't have pencil and paper, we got to solve for C basically, right? So the correct order would be like this. You divide P by N, divide both sides by that, right? And what I would do in this case, right? Sometimes a mistake people make is they subtract 19 first. Not the best way. I would think about it this, right? Move the C, negative C to the other side. So we're going to add C. So it becomes C on this side. And then subtract the P over N, right? So you kind of swap them, because then your C is positive and you're done, right? If you subtract the 19, you got to divide by a negative, and sometimes people kind of mess that up, right? So that would be D. That would be doing it algebraically. But there's a way you can kind of do this in Desmos. You see, if I do write this in Desmos, right, it's not going to draw me anything, right, because it doesn't know what these things are, right? So Desmos wants to see like X, Y, and numbers, right? So generally it's not going to like things when you have like other variables, right? So if I want to see a graph for this, it's pretty simple actually. Here's what I'll do. I'll just change this, right? I'll change P to be Y. Actually, let me write this on the next line. Y equals X and then 19 minus. I'm just going to make up a number for C, right? This says, they're positive numbers, so you probably want to pick a positive number. I'm just going to make it 5, right? So, it doesn't matter that P is Y, X is N, and C is 5. You could have made X something else, Y something else, and something else the number. Just never plug in 0 and 1, right? So here's the cool thing, right? Now that I've got these kind of like lined up, I see what this looks like, right? One of these has to match, right? That's the idea. If it's the same equation, it's going to match. So this is a pretty cool hack to know. So you see, if I enter an A, right? A is C equals, so C was 5, so 5 equals, and it'd be 19 plus P, which was Y, over X. You see, it's going to graph it, and then you see, I know that's not correct because it's not the same graph, right? So we already know what the answer is. It's D. I'm just going to jump down to that one. So you see, if I write that instead, 5 equals 19 minus P, which was Y over X. You see, they're the same exact graph, right? And so then that's how I know that's the correct one, right? So you might not need it for this problem, but it's a pretty cool hack to know. Can help you out, right? If you're kind of stuck on algebra, it shouldn't matter, right? If you kind of know this, you should be able to answer regardless, right? But sometimes algebra is faster, so that's it. Good one to know. Next one. The length of an edge of a box is 29 inches. Each side of the box is the shape of a square. It does not have a lid. What's the exterior surface area, right? So what they're basically describing here, right? We have kind of surface area somewhere. Here it is, right? This is their favorite shape to use, a rectangular prism. But sometimes you get variations of this. You can get a square prism or you can get a cube. So in this case, they're describing a cube because they said, each side of the box is a square, right? And that happens with a cube. So you see, you can memorize these surface area formulas, or you want to be able to basically derive it, right? This is given to you. The rectangular prism is the one that's given to you, not the surface area, the volume. You got to know surface area is just the area of all the sides. So if you look at that object, you should be able to kind of come up with this formula. If you can't, maybe it's something you want to memorize, right? Because you definitely kind of run into it. So here we're dealing with a cube, right? And it's a cube without a lid. So it's not going to have 6 sides. So it's not going to be 6x squared. It's just going to be 5x squared, right? And so that's going to be our answer. It's just going to be 5, and then x is the side length, so it's 9, right? So it's 9 squared, so it'd be 4,205, right? So that's it. Next one, this one's an easy one. Again, sum of the solutions. And once the solutions, that's a big key word to remember. Any equation, doesn't matter what it is, here's the absolute value. You see, I put it in, I see my 2 lines, these are my 2 solutions. Sometimes you can't click on them, for certain functions, doesn't let you click on it. What you do, just zoom in on it, you can see it. So this one's -9, and this other one over here was, 27. So -9 plus 27 for the sum, we get 18, right? So that's it. All right, next one, another freebie, right? Just throw that into Desmos, tan 92 pi over 3, right? The only thing you got to know is Desmos by default, you see if you click this tool wrench, it's always in radian mode, right? If you start afresh like Desmos, you might need to swap it to degrees, because you see if I change the degrees, totally different number, but we want to be in radians, right? You're only in degrees if you see a degree symbol, right? So this is our answer. I just got to see which one of these it is. So it's got to be A or B, right? You might already know this if you're kind of familiar with the unit circle, but yeah, it would be A, -√3. Okay, next one. Here's a equivalent problem that we can kind of do in Desmos, right? You could do algebra here. Honestly, I wouldn't. Here's what I would do, right? 42a over k plus 42ak, right? So if you see, if I put this into Desmos, it's not going to give me anything. It's not going to give me a graph because it's not an equation, right? And it's not going to give me any value because it doesn't know what a and k are. So what I would do is just tell it, hey, let's make a 3 and let's make k 4, right? And now I have a value. And what equivalent means is that one of these has to be exactly the same, right? So now you see, I can just enter in answer choice A, right? And it tells me it's 63 under those conditions. That's not the same thing. So then I can try B next, right? That's not the same thing, right? Then I can try C, 42A times K plus 1. That's not the same thing. And finally, you see, I change it to D, and now they match, right? So that's how I know D's the right one. And you can see I can change these numbers to some other numbers, and they're always the same, right? So that's a good one to know. Very common. Next one here. Circle equation. Circles, just things you can put in Desmos, honestly, right? If you have an equation, you see I just type that in, plus y minus 19 squared equals 121. Okay, I zoom out where it is. Let's reset our view. There it is. There's our circle. The question, it says, the point AB is on, the circle. What's the following point for A, right? There's a few ways you could do it. A just represents our X value. So you see, I can just say like X equals, -16. And I see that's not on the circle because it doesn't intersect the circle. -14, that's going to be our answer. Let me show you the other ones. 11, you see not on there. And then 19, also we zoom out, not going to be on there, right? So it's just going to be -14 we said. Yep, okay. Next one here, it says a right rectangular prism has a height of 9 inches. The length of the prism's base is x inches, which is 7 more than its width. Which function v gives the volume of the prism? Okay, cool. So what we kind of want to revisit is this, rectangular prism and volume, right? Volume is length times width times height, right? So that's kind of what we have to know, length times width times height. You see, they're telling you that the height is 9, right? So it'd be like length times width times 9. Now, this is the part people mess up. It tells you the length is x, right? So length has to be x, right? But then people read this. They read 7 inches more, so they're inclined to pick x plus 7, right? That wouldn't be correct because what we're missing to fill in is the width, right? The length is 7 more than the width. Another way of saying that is the width is 7 less than the length, right? So the correct thing that you want here is you want x minus 7, right? So putting all that together, that's how we end up with D, but C is the trap answer here that most people get stuck on. Finally, this is a really kind of like hard one actually, right? So generally like most of the stuff shouldn't be too bad in module 1, but there could be one kind of hard problem or two possibly, right? So over here, you get this square root function, right? So if I kind of type this in, obviously nothing is going to show up because we don't know what A and B are. And it says, in the XY plane, this passes through this point and f of 24 is less than 0, which must be true. So here's the thing, I can actually figure out what this equation is, right? I just got to do a custom regression. Here's how that works, right? Add a table, you need 2 points. One point is really clear, -24, 0. Next point says 24 less than 24 for x and y is less than 0. Doesn't matter what we make it, just make it something less than 0. I'll go with -6. Now I got this. Now I'm going to write my custom regression, right? So the way a custom regression works, right? It's pretty simple. You see the table uses x1, y1. You got to use that, so notice to refer to the table. We'll write y1, and then instead of an equals, use a tilde, and then we get this x1 plus b. So you just replace y with y1, x with x1, the equals with tilde. And you see, now I know what my a and b are, right? So now I can kind of like write this as like a function. Let me go back to this, right? So I can write negative 0.866025. We don't actually need all those numbers, but what the hell? And then 24. So now I have my function, right? Why do I want my function? Because now I can test out, you see, like a, f of 0. What's f of 0? Well, it's this number. It's neither, 24 nor -24. So those are wrong. So then that leaves me with a and b. And you see, I know what a and b are, right? A is negative, this number, and b is 24, right? So a is less than b, right? So that's it. And that's it for Module 1. Quick break before Module 2. Want to show you something I built. Here's the reality about SAT math. Watching someone else solve problems does not make you better at solving them. What makes you better is doing hundreds of them yourself until you stop thinking and just solve. When you've done 50 linear equation problems, the 51st one isn't even a question anymore. You just see it. That's the level you want to be at before you walk in. All of these are obvious to me just because of practice. That's why I built Sigma Prep. Every SAT math topic organized by difficulty. You pick a topic, you practice. Every time you get a question wrong, there's a video explanation of me breaking down exactly how to solve that specific problem. You watch it, you retry it, you lock it in. No more getting stuck and wondering what you did wrong. Let me show you real quick. Say I jump into this topic here, I get a question, I answer it. If I get it wrong, right here, video explanation. I can watch exactly what I would do, then try it again. Every topic works like this. Every topic is free to try. Jump in, start practicing right now. And if you want to know where your weak spots are, take the diagnostic quiz first. You'll come out knowing exactly what to focus on. Bottom line, if you put in real reps with real feedback, there's no way your score doesn't go up. SigmaPrep.io, link in the description. Back to Module 2. Let's take a look at this. So a right triangle has legs of 11 and 9. What's the hypotenuse? This is just Pythagorean theorem, right? So you could just do that in Desmos actually, right? So it's like a squared plus b squared. Those got to be your legs, and then equals x squared for the hypotenuse. You see, I can just click on my answer. It's 14.2. Which answer is that? Well, it's not, C, it's not D, it's going to be B. If you want to know for sure, just type that into Desmos, you see, and we can kind of verify those are the same, right? So that's something you kind of want to know, is just Pythagorean theorem. It's pretty common. Next one here, we did one like this in Module 1, right? They wanted to basically know what's the equation, and they give you 2 points, right? So hopefully you remember this one, right? Certain things, definitely going to repeat. So I put in my 2 points into the table, right? And I just press the regression button, and I get my equation, 2x plus 7, right? So that's it. Okay, next one over here. It talks about kind of like margin of error, right? Do I have something about margin of error? Let me take a quick look. I might not. But margin of error is pretty simple. I thought I did. I might not. Okay. So, yeah, no, okay. Margin of error is just plus minus. That's how you can kind of think of it, right? So usually it's in terms of a percent. So like here they tell you 12% of the socks were defective, and there's a margin of error of 3.62%. So you want to think of it as like 12% plus minus the 3.62%, right? So if you do 12 plus 3.62, right, it did the minus up there. It's got to be between, these two numbers, right? And that's what we want to say. We want to say this is the most likely range. So that's what kind of B says. It's the plausible range, right? That's typically where you're going to see. And if it's a number outside of that, it's not that it's impossible. It's just that it's unlikely, right? So there it is. Next one here, this is just a reading problem, right? It says a truck can hold a maximum weight of 5,630 pounds. During one trip, it will be used to haul a 190-pound piece of equipment as well as several crates. Some of these crates weigh 25 pounds each and others weigh 62 pounds each. Which inequality represents the possible combinations of the number of 25-pound crates, X, and the number of 62-pound crates, Y? Okay, you got to make sure you use everything, right? Sometimes people are going to pick like C and D. Those are wrong just because we're not going to be utilizing this 190, right? So the 190 comes from, that piece of equipment weighs that much, so we don't have that, available to us, right? So we got to subtract it. That's where the 5,440 comes from. And finally, then it just, like the inequality signs, right? That's really it. That's the maximum weight. You can't be more than that. So you got to be less than that, right? So that's why we want a less than or equal to. Okay, next one, freebie. This is the first system we saw, right? Usually you get a few system problems, I feel like, right? System, just type it into Desmos, you see, and then just click where they intersect, -2, -5. That's it. C is our answer. Range. Okay, so range is from statistics, right? Here's statistics. There's 5 things you got to know, right? Here's range. Range is largest minus smallest. So you take your largest number, 52 minus the smallest. Just make sure you got the right one. So 52 minus 23, 29, right? Got to know that one. Desmos can't do it. You can't write range and give it the numbers, so that's one you kind of have to know. Next one here. So here we got another system of equations problem. This one's not as obvious. So this is obviously harder, right? The way I know this is a system of equations problem is a system is used when you have 2 unknowns, right? So here they describe like we're purchasing some amount of bread and some amount of eggs, right? So if there's 2 unknowns, right, that's typically going to be a system. So this sentence here is going to give us one equation. One customer paid $12.45 for 1 loaf of bread and 2 dozens of eggs. Two dozen eggs, yeah, okay. So I can write that as an equation. It'd be 12.45 equals, let's say, 1x plus 2y. X is going to represent loaf. Y is going to represent the eggs. Second customer, 19.42 equals 4x plus 1y, right? And that's it. Now I have it. I can click on it and just make sure we answer the right one. It wants to know the eggs. Eggs, I made Y, right? So you want to pick that. You see, they also have the X there, so just make sure you're answering for the correct one, right? So that's it. Next one, another system, right? So here are all our system ones. They weren't in module 1, but they're here, which is kind of nice because they should all be freebies, right? So here it is. You see, I put in my equations. They don't intersect each other, so that's going to be 0 solutions, right? So where they intersect, those are the solutions. If they don't intersect, no solutions. Simple. Another system. Wow, yeah, just come in bunches. I was going to say, like, typically you have like 3, 4, 5, system problems per test, right? All of them should be freebies, right? Make sure you don't miss those, right? So here it is. Now I can click on my solutions. It's these 2. It says, what's the greatest possible value for X? So it could be -9, it could be -6. So it's going to be -6 in that case, right? So that would be it. Next one here says line P has a slope of -5/3 and an x-intercept at -6, 0. What's the y-coordinate of the y-intercept, right? So there's a couple ways you could do this, right? Remember, it's kind of like the same table regression thing, right? They give you 1 point, right? -6, 0, right? But we need a second point. So how do I get a second point? Well, you could just use the slope, right? The slope will be down 5, right? -5, so that's the y. And then to the right 3. So if I went to the right 3 from -6, it'd be -3. Hit the regression. Here's my equation. Can click on the y-intercept. It's just -10, right? Or you could just kind of continue the slope one more time and you'd kind of see that as well. But that's how I can do it with Desmos. Next one here, how many solutions does it have, right? I kind of feel like some of these are easier than what module 1 was, right? So it's not like too crazy, honestly. So you see, if I type this in, remember, if you just type an equation in, Desmos will find you the solutions if there is, right? So here it is. There is a solution. The lines represent your solutions, right? So like there is one solution here and that solution ends up being 0, right? Don't pick 0. 0 is the solution, right? And there's one solution. Here's what it would look like if there was no solutions, right? You'd literally not see anything, right? So actually that was like infinitely many solutions. So even with infinitely many solutions, you don't see anything. You got to kind of be careful about that. If you got a situation like this and you don't see anything, what you want to do is separate them. You see, I can write on one line 2x and on the other line 2x plus 4. And then I can just see like, are they parallel? Or like if it was infinitely many solutions, you see they'd be like right on top of each other, right? But yeah, this is a common question. How many solutions? Just type it in, see how many lines show up, right? Like for instance, we don't have a quadratic, but if I did, you see 2 solutions for this quadratic, right? So the amount of lines is the amount of solutions. So that's it. Next one here, Kailani used fabric measuring 5 yards in length to make each suit for a men's choir. The relationship between the number of suits that Kailani made, X, and the total length of fabric she purchased, Y, is represented by this equation. What is the best interpretation of 6? This is just a reading problem, right? So they basically kind of tell you most of these things, right? So it says, Kailani purchased fabric 5 yards in length to make each suit, right? That's what this 5 represents, right? It's kind of like how much yards we need per suit, right? They also told you what X is, and you see you can start to eliminate things, right? So if it's 5 yards per suit, right, then, these two probably don't make sense, right? You wouldn't have purchased 6 yards if you need 5 yards per suit. and you wouldn't have used a total of 6 yards, right? Because you'd be able to make what, 1 suit at most, right? So yeah, it's not going to be either of these, right? And then furthermore, it tells you X is the number of suits she made, right? So we don't know it's 6 suits because X is the number of suits, right? And then Y was the number that was purchased, right? So it's not that either. And like we said, this one doesn't really make sense. So it's the amount that's left over. So you can think about it, purchased minus used equals leftover for the 6, right? Okay, this one, which one has no solutions? Just type these in, right? You know, so maybe there's other ways to kind of do it, but just type it in. You see, if I type in this, 2 solutions. If I change the signs for B, it's minus 14x plus 49, right? 1 solution. If I change it to C, right, 5x squared minus 14x, all right, so that has 2 solutions. So it should be D. Let's check it out. Make that a plus 49, and there it is, right? Here we don't see anything, so D's our answer. Next one here, the function f is defined by the given equation. This is an exponential one. It says can be rewritten. Rewritten is an important word. It's kind of like equivalent. It means they got to be the same, right? So this and this have to be the same, and they're kind of asking us, like, for what value of p will this be the same as this? So here's what you can do. You just type that into Desmos, and you can see what it looks like, right? And then again, just kind of understanding the question. It's saying that, like, this other one that I type in with the p, right? This has to be basically the same thing, right? It's not going to be exact because it says closest to, right? But we want to see for which p value is it going to be closest to. So you see, if I try p is 16, those look pretty close, right? They're almost identical, right? And then if I change it, if I try 21, that looks worse, right? If I change it 46, that looks worse. And if I change it 96, that looks worse. So 16, that's going to be, you know, the one that's the closest to it. So that's it. Not too bad. Next one here, it gives us a system, right? And it says, in the given system of equations, p is a constant. If it has no solution, what is the value of p? I have something for this. Where is it? Here it is. No solutions. We kind of saw this a little bit earlier, mentioned it. It's just going to be when they're parallel, right? So we kind of want to figure out what value of p is going to make them parallel. There's 2 ways to think about it. I'll show you one way with Desmos. You could use a pretty cool trick with Desmos, the slider, to find it pretty easily, I think. Or it's basically just kind of understanding here, they have to be the same slope, right? That's what kind of parallel implies. So they tell you p is a constant, right? You'll see that phrase a lot on the test, right? All that means is it's just a number, right? Because you have variables and you have constants, right? Variables are variables, constants are numbers, right? So here it tells you p is a constant. So you know, like r and w are your variables, right? So if you type it in with r and w, Desmos is not going to like that. So I'm going to change r to be x, right? And I'm going to change, you know, w to be y, right? So if I do that, these 2 equations would look like this, right? Plus 11, okay? And so you see, it drew this one because nothing's missing, but it didn't draw this other one because it doesn't know what p is. That's the question. This is a very common question. You'll probably get this most tests, I would say, always here in module 2. Just click this slider, right? And you see, I can just kind of like move this slider until I find the value that makes them kind of parallel. Typically it's an integer, right? So here it's 10. Just zoom out, make sure if you kind of move to either side, it remains like parallel, right? And it does, so that's it. So that's a cool trick to know. Otherwise, you can rearrange them to slope-intercept form and, you know, set their slopes equal to each other, right? But the slider, you know, that's usually the fastest way if that works. This one over here says the graph of 2x squared plus bx plus c, where b and c are constants. What's the value of bc? This is a quadratic, right? You could do a quadratic regression, right? They're not as common as the linear regressions, but you see, I add my table. The only thing you want to remember is a quadratic, you need 3 points, right? The linear equations, we just needed 2 points, right? So here, it's -2, -6. That's our first pair. Then we got -1, -8. And then we got 0, -6. That's the third pair. Smash the regression button there, change it to quadratic regression, and you see 2x squared plus 4x minus 6, right? So b is 4, c is -6, right? So that's going to be -24, right? Simple. Next one here has to do with transformations. We talked about this a little bit earlier, right? You see f of x plus 19, right? If we see that f of x plus 19 is shown, what did that mean again? It meant it was f of x shifted up 19. Now, it's important you kind of understand what they're telling you is shown, right? Sometimes people make the wrong mistake. They shifted the wrong way. They're telling you that this is the result after we moved it up 19, right? The question then wants to know just about f of x, right? So if what I'm looking at is f of x after it was moved up 19, right? Then, you know, where's the original f of x? Well, it's going to be 19 below, right? So like, here's an example. Let me just kind of make up like a equation here. So you see, I can write something like this: f of x equals, let's say 2x minus 16, or let me make it negative so it looks the same. And then you see I can do like g of x equals f of x plus 19, right? So this is the one we're looking at. So whereas again, f of x is just below, right? The reason that's important is we kind of have to understand that, you know, f is going to have negative slope and a negative y-intercept, because again, f is 19 units relatively below this one, right? So we want the answer choice basically, because they don't give us numbers here, right? We just want to know like which one has negative slope and negative y-intercept. So that's A. So hopefully that makes sense. Next one here, we have these triangles, right? So this is similarity, right? Where is similar? Similar figures, right? So two things to remember: corresponding angles are equal, corresponding sides are proportional, right? I know these are similar, even though it doesn't tell me they're similar. Whenever you have this image where it's a triangle inside of another triangle, that's similarity, right? So basically what you'd want to do is kind of like separate these two triangles, right? I'm not going to draw it out here just because I don't have the ability to, but you want to separate that because it makes it a little easier to see, right? So the reason you want to separate is you want to kind of know like what this ratio is, right? You want to compare like one side to like another side, right? So here what we're going to compare is, like you see, we know AC is 3 and then CE is 21. So AC is 3 and then the whole thing is 24, right? So the bigger triangle is 8 times bigger, right? That's what you kind of have to know. So the mistake people will make is think 7 times bigger, but it's not, right? Again, if you draw it out, it'll kind of make a lot more sense that way, right? So it wants to know what is the area of triangle ADE, right? So if you want to know the area of a right triangle, you just need to multiply the legs together, right? Base times height times a half, right? So we know the base, right? And then we got to figure out this height, right? And it kind of comes from the proportionality. So we want to figure out BC over here, right? So the way we can do that is just Pythagorean theorem, which we did, I think, for the first question of this module, right? We know this is 3. We know this is root 34. It's just Pythagorean theorem. So you see, I can say x squared plus 3 squared equals square root 34 squared, you see, and it'll just figure it out for me. So this side is 5, and therefore I know this big side, which I'm trying to figure out, is going to be 8 times bigger, so that's 40, right? So DE is 40 over here, and then, you know, AE is 24, right? So those are two sides I need, so it's 1/2 times 24 times 40, right? So I hope that made sense. I wish I could draw it out. It'd look a lot better, right? But that's kind of it. So 480 would be our answer. All right, next one, another percent question. So we talked about this earlier. You want to be able to kind of like, let's see. Yeah, you want to be able to kind of translate these. I don't know if I have something exactly for this. Not exactly. So this is more about like this equation for like percents. I guess it kind of fits, but not exactly. Yeah, I mean, it fits. If you have like percent increase or decrease, which we do here, you got to make sure you multiply by 1 plus or minus r. So yeah, this does kind of relate to this. So you should be able to just translate this into an equation and get Desmos to give you the answer. It says the result of increasing x by 400%, right? So we're going to take x and we're going to multiply by an increase of 400%, right? The word increase is super important because you got to know to change it to 1 plus r in that case, right? And then is your keyword for equals. So you see, this is my equation. If I can translate that, and that's super obvious, you see, you can just click on your answer and you know it's 12, right? This problem here, probably a crazy one. Sometimes you get these like crazy ones here in Desmos, right? So what I would do for this one, it says we have a center HK, A and B are on the circle. A has this point, right? Okay, so just make up numbers for H and K. I'll go with 0, 0, right? So this is going to be our center. So then, you know, point A over here is going to be 1 comma square root 102, right? I can even give it that label, right? A. And they want to know what B would be, right? So the way you figure out B is they tell you, right, that ACB is going to be a right angle, right? So this is C over here. So if it's a right angle, these are perpendicular to each other, right? So if this was like, we think about the slope over here, it's rise over run, it's up square root 102 over 1. This will be just the negative reciprocal. So it'll be down -1 and over square root 102, right? So that would be this point. It'd be square root 102 comma -1, right? That's going to be B in that case, right? And then finally, right, they want to find the distance of A and B. So this isn't something you really use that often in SAT. I haven't kind of seen it, but you can literally type in, you know, kind of like distance and then give it 2 points, right? So point A was this, 1 comma square root 102, comma, and my other points, square root 102, comma, -1. And you see it'll give me my distance. And then I know it's got to be basically A, because this is too big. This would be like 20. These are way too big, right? But again, you see, if I just put that in Desmos, I can just verify these are the same number, right? So that's it. All right, next one here. This is just kind of like a big word problem. So just read it kind of like one sentence at a time. The first sentence here is super important because it kind of gives you an equation. It says electric field passing through a flat surface perpendicular to it. The electric flux of the field through the surface is, so remember that's a key word, and product, right? Product means multiplication. So we basically say this. It's saying flux equals the product of two things. It says the strength and the area, right? So this is going to be like our equation. That's what we kind of have to pull out from that first one. So then it says a certain flat surface has two adjacent squares where the side length in meters of the larger square is 3 times the side length of the smaller one, right? So let's just we can make the small one, small side be x, right? And then the large side, for the bigger one is going to be 3x, right? Just 3 times bigger. So what I can do then is I can find the area for that, right? If we know that they're squared, so it's just the side squared. So you see, now it tells us the electric field of a strength of 29. So in this equation, you see, I know strength is 29, passes through this surface, right? Which is like, I got to know area, right? So area for the small one's x squared, for this one's 9x squared, so it'd be 10x squared, right? And you see, then they tell me the flux, right? The flux is 4,640, right? So you see, with all that, I can basically kind of figure out, what x is, right? So x is 4. Final question then, right, says, what is the flux, right, through just the larger square, right? So I know x is 4 now, therefore you see I can figure out the side of the large square, it's 12. And so again, if I want to figure out flux for just the larger one, I would take, strength, which is 29, and multiply by the area of the larger one, which would be 12 squared. So that's 144, so that's 4176. So both those problems there are kind of a little crazy, to be honest, right? Like that's the thing with module 2, right? Is, you will get maybe like 1 or 2 like pretty challenging ones. Honestly, if those are the ones you get wrong, you'll still have like a near perfect score. So I really wouldn't sweat those like initially, but everything else, is just things you're going to constantly see besides maybe like 20 and 21 that we kind of saw here, right? Finally, 22 here. This looks like a good one. We see scatter plots a lot, right? So basically it just wants the equation, but let's see. It says scatter plot, shows the relationship between two variables for data set E. This for data set E. It says a line of best fit shown. Data set F is created by multiplying the y-coordinate of each data point from data set E by 3.9. Which of the following could be the equation of a line of best fit for data set F? The mistake people make is they just kind of like, take the points from what they see and they don't kind of make any changes, and they have a trap answer waiting for you, right? So we did this a few times. If you want the equation of a line, just throw it into Desmos, right? But the change I got to make, you see, is they told me data set F is created by multiplying the y-coordinate of data set E by 3.9. So I got to take 2 points here. I'll take this one. It looks like 2 and 15, but it's not going to be 15. It's going to be 15 times 3.9, right? Which I could just write in there. And then I'll take this one. It's 18 and 40. So it's not going to be 40, but 40 times 3.9. Do my regression, and here's my answer, right? I want to see which one's kind of the closest. So yes, y-intercept of 46, so definitely, A or B. And then this slope is about 6, which is closest to 5.9x, right? So that's basically it in that case. That would be it. About 20 minutes there also for module 2, right? Yeah, so not too bad. Again, other than 20 and 21, I think all of those questions are things you will routinely see, right? And so if you're kind of familiar with that, right, then there should be no surprises, right? And there it is, perfect 800 on practice test 5. Every single question, every shortcut, every Desmos trick. If you want to practice like this yourself, go to sigmaprep.io. Every single SAT math topic with practice problems and video explanations. Free to start, link in the description. Like and subscribe. The next test is coming soon.